Question 26, Part A. At a World Cup rugby match, the stadium was filled to capacity for the entire game. At the end of the game, people left the stadium at a constant rate. The graph shows the number of people, N, in the stadium T minutes after the end of the game. The equation of the line is of the form N equals A minus BT, where A and B are constants. Part 1. Write down the value of A and give an explanation of its meaning. Rearrange the linear equation into the form y equals mx plus c, where m represents the gradient of the line and c represents the y-intercept, or where the line crosses the y-axis. Now the linear equation that's presented in the question is n equals a minus bt. So rearranging this linear equation into the form y equals mx plus c, we get n equals negative bt plus a. So notice that a is positive, and I've written it as plus a here, and bt is negative, so I've carried the negative with the bt, hence n equals negative bt plus a. Now negative b represents the gradient of the line, and a represents the y-intercept. So we can observe from the graph that the y-intercept is 60,000. So from the graph, the y-intercept is 60,000, therefore A equals 60,000, which represents the number of people in the stadium just as the game ends before anyone has left. Part 2. 1. Calculate the value of B, and 2. What does the value of B represent in this situation? B represents the gradient or the slope of the line and is found using the expression rise over run or rise divided by run. Now in this case, the rise is 60,000 and the run is 30. So B is equal to rise divided by run, which equals 60,000 divided by 30, which simplifies to 2,000. Now B represents the rate at which people are leaving the stadium per minute, and in this case, it's 2,000 people per minute. Part 3. Rearrange the formula n equals a minus bt to make t the subject. Starting with the equation n equals a minus bt, add bt to both sides of the equation such that negative bt plus bt equals 0, which cancels out the negative bt term, but then we end up with a plus bt term on the left-hand side. So the equation now is n plus bt is equal to a. The next step is to subtract n from both sides of the equation, which cancels the n on the left-hand side. So the equation now is bt is equal to a minus n. And the final step is to divide both sides of the equation by b. Since b is multiplying t, the inverse or the opposite operation of multiplication is division. So we cancel the b term on the left-hand side by dividing by b on both sides. So we end up with t is equal to a minus n all over b. Part 4. How long did it take 10,000 people to leave the stadium? N represents the number of people left in the stadium at time t. Now from part 3, the formula was rearranged to t equals a minus n all over b, which can be written as t equals a minus n in brackets divided by b. Now A is equal to 60,000, which is the initial number of people in the stadium. Now after 10,000 people leave the stadium, we have 50,000 people left, so N is equal to 50,000, and B is equal to 2,000, which represents the rate at which people are leaving the stadium each minute. So substituting those values into the formula here, we get T is equal to 60,000 minus 50,000 in brackets divided by 2,000, which equals 5. Therefore, it took 5 minutes for 10,000 people to leave the stadium. Part 5. Copy or trace the graph of n against t shown above into your answer booklet. Suppose that 15 minutes after the end of the game, several of the exits had been closed, reducing the rate at which people left. On the same axes, carefully draw another graph of n against t that could represent this new situation. Your new graph should show n from t equals 15 until all the people had left the stadium. This line here is the original graph, which shows the number of people left in the stadium t minutes after the game ends. So originally, we have 60,000 people in the stadium right at the end of the game. 2,000 people per minute leave the stadium, which means that after 30 minutes, there are no people left in the stadium. Now we're given the situation that at the 15-minute mark, some exits are closed. So after 15 minutes, we have 30,000 people left in the stadium, but the rate at which people leave the stadium has decreased. And that's shown by this interval here and here. So notice that the gradient is shallower compared to the gradient here. So we can see that this particular situation that I've drawn shows the stadium empty at the 60-minute mark rather than at the 30-minute mark.